We are looking at some examples similar to the week 6 homework problems. First off, here we have a researcher is conducting a study to determine the mean trough dosage of a medication for a population. So for a population, so single population, we're looking at the mean. Assuming a previous study was collected for the same medication and the mean trough dosage was found to be 320. So that's telling us that previously our mean was 320. And then, so that's mean 320. And our standard deviation was 25. So that's telling us sigma is 25 here. Calculate the margin of error. So we want E, the margin of error, for a 99% confidence interval, assuming the previous study enrolled 200 individuals. So that's N. So N is equal to 200. And so for 99% confidence, the z-value that goes with that is 2.576. That's table 1b. So if we go to table 1b, so here's table 1b, 99% confidence, 2.576. So that's where we get that value. And if we plug those into the formula for margin of error here, 2.576, 25, and 200 gives us 4.55 milligram margin of error. Problem number 2, same background here. We're finding mean trough dosage here. So we want mean trough dosage for a population. So that's going to be continuous variable, one sample. Our previous mean was 320, standard deviation 25 like we had before. Researcher wants to be, let's see, 99. We want 95% confident there. Sorry about that. So we actually want 95% confident. That the true mean dosage is within 15 milligrams. What sample size is needed? So the 15 milligrams, that is your E. So our sigma is still 25, our E is 15, and then the z-value that goes with 95% from table 1b is 1.96. So 95%, 1.96 right there. So if we do the plugins there, we get 10.67, which we round up to 11. Sample size, you always round up to 11. We can also do this using the Excel online workbook for sample size. Let's take a look at that. So this is Excel workbook sample size determination. We've got mean and one sample. So this is sample size for confidence interval, and we were doing confidence interval rather than hypothesis test for the mean. So our confidence level is 95, and then our standard deviation 25 there, our margin of error 15, and we can see our sample size 11. So that is confirming n equal 11. So you don't have to do the formula, but I want to show you here that the formula and the Excel online workbook give the same answer. Next question, again, same background here, except one change here. We've only got an 88% retention rate. Now, if we had a 100% retention rate, we would just need 11 participants like we did before. With an 88% retention rate, only 88% of the participants are going to complete the study, so we need a larger starting sample size. So the way you compute that is your sample size is going to be 0.88 times cap n, which is your starting sample size. So if you solve for that cap n, you have to take your sample size at 100% retention divide by the 0.88. So 11 divided by 0.88, 12.5, rounded up to 13. Well, we can also do this with the Excel online workbook, that same tab, tab 1. All we do here is enter the expected amount to be lost. Well, if 88% is retained, that means that 12% is lost, and there's our 13. Problem number 4, we've got a researcher wants to calculate the prevalence of iron deficiency anemia among members of a specific community who are 50 years of age and older. Researcher needs to know how many individuals who are 50 and older need to be recruited for the study, so it's sample size, to ensure the estimated prevalence will be within 2%. So that is telling us that E, the margin of error, is 2% or 0.02. Of the true proportion. So this is a proportion test, and calculates the sample size needed by the researcher if we desire a 95% confidence, and the national study shows 8.2% of individuals 50 years of age have iron deficiency anemia. So that 8.2%, that is our P, our proportion in the population, so 8.2%, 0.082. And then we are doing a confidence interval because they tell us 95% confidence. So we need sample size for a confidence interval of proportion. So if you look at table 8.1, you see continuous outcome, continuous dichotomous outcome, one sample. Right there, P1 minus P, Z over E squared. That's where I got this formula. And the Z value that goes with 95% confidence from table 1B is 1.96. If we do those plugins, we get 722.95, rounds up to 723. Let me show you how to do that with the Excel online workbook. So we go to our workbook. This is sample size for confidence interval for proportion. So it's tab 2. We do want 95% confidence. Our estimate of the true proportion, that's the 8.2%, so 0.082. Our margin of error, that was the 2%, 0.02. And we don't have any percent that's expected to be lost. There's our 723, which is the same thing that we got here. So look for those keywords to determine which sheet to use inside the Excel, which tab to use inside the Excel sheet. 5, we've got a clinical trial to determine the efficacy of a new drug that will be used to treat diabetes. So we're going to determine that using a blood test to examine hemoglobin 1AC levels. If the researcher wants the margin of error for the level of H1C to be less than 0.15, so that's E equals 0.15, so that's right here. And if the standard deviation of the H1AC levels is documented to be 0.40, so that's saying sigma is 0.40 there. And we're assuming 95% confidence interval, so it's a confidence interval we're looking at. And we're going to quantify the mean differences between the control group and treatment group. So this is going to be continuous. H1AC is continuous. It can vary continuously. It's going to be two sample confidence interval estimate because we've got control group and treatment group. So that formula is right here, continuous 2 sample from table 8.1. So if we look at that again real quick. So we've got continuous outcome 2 independent samples, and right there is your formula. So that's how I got the formula. These are our variable values. If we plug those in here, we'll get 54.6, approximately 55. Let's do it with the online workbook. So with the workbook here, we want 2 sample confidence interval. So we've got confidence interval here for mean 1 minus mean 2. That's 2 independent samples. MD, that's the mean of the differences. This is the difference of the means. So we want actually tab 4. And then let's see here. We are going to do 95% confidence. So 95 there. Our standard deviation, that is the 0.40, margin of error 0.15. So 0.40, margin of error 0.15, sample size required 55. And that is what we saw here. So again, 55. And notice this is sample size per group. Problem number 6, researcher wants to be sure that the mean difference here in change in heart rate has a margin of error no more than 10. So margin of error 10, so that's saying E is 10, that's right here. And mean difference, that's going to be M sub D, the mean of the differences. And then let's see, standard deviation between the mean heart rate from the first medication for tachycardia to the second medication is 22. So that's here, sigma D is 22, so the standard deviation of the differences. Compute the sample size required to ensure accuracy with 99% in a crossover trial. So although they've mentioned a crossover trial here, they've given us not a significance, level of significance, but what they've called accuracy. We really should interpret that as 99% confidence because they haven't given us a power for the test, and you would need that to determine sample size for a hypothesis test. So this is a continuous variable. Okay, the mean difference is continuous, and then it's 2 matched samples estimate. So if you look at table 8.1, if you want to use formulas here, we've got right here continuous outcome 2 matched samples. So Z sigma D over E quantity squared is your formula, and that is this one here. So sigma and E we were given from the problem. The Z value that goes with 99% from table 1B is 2.576. We do those plugins, we get 33. 33, and in a crossover trial, each subject acts as their own control, so that n equal 33 is actually 33 pairs. You don't need an additional 33 subjects because the 33 subjects that take the first medication cross over and then take the second medication. Now, if we want to do this in the Excel online workbook, we'll use tab 3. So tab 3, come back here, that's confidence interval for mean difference. So M sub D. So we want 99% confidence, margin of error 10, sigma 22. So standard deviation of the difference 22 there, margin of error 10, and we can see our 33 sample size required there. And that's this 33. So it does agree with what we did by hand. And then lastly, a researcher wants to estimate the impact that prenatal care during pregnancy can have on birth defects by conducting a retrospective case control study. So you're going to have exposure, non-exposure groups. So that's going to act like 2 populations or 2 samples. If the prevalence of birth defects is approximately 5.3%, that's going to be our P. That is right here. P is 5.3% or 0.503. How many subjects, so we want sample size, should the researcher enroll in the study if they want to construct a 90% confidence interval? And for the difference in proportions, so that's going to be P1 minus P2, that has a margin of error no more than 4%. So our E is 0.04, 4%. So if we look at table 8.1 here, we've got confidence interval here, and then we've got two independent dichotomous, 2 independent samples. That's difference of proportions. That is this formula. And that is right here. And our Z value that goes with 90% confidence from table 1B is 1.645. P1 and P2 are both the same. They're both 5.3%. And so we have everything, so we make the substitutions here. and compute, we get 169.77, rounds up to 170. Let's use the online workbook to do it. So this is going to use tab 5. Let's see why. So tab 5 here, this is sample size N1 and N2 for confidence interval for P1 minus P2. So a confidence interval for the difference in proportions. So we've got 90% confidence. So our confidence level, 90. The estimate of the true proportion, that was the 5.3%, so 0.053. And then in the second population, also 0.053. Margin of error, that was our 4% right here, 0.04. And sample size required, 170. There's no percent expected to be lost, and we see that that 170 agrees with what we did by hand. So I wanted you to see where to get the formulas and how to use them. So if you run across them in the textbook, you at least know where they're coming from. For the homework and the exams, you can feel free to use the Excel online workbook. And all you have to do is just, if it's someplace where you need to show work, like an exam, just note that you use Excel online workbook. So EOW, you can abbreviate that. And then state the tab that you use, and then just state your values here. So, and that would be enough work to get partial credit in case something went wrong in there. Of course, if you do everything out by hand, that's okay too. And if you make a little mistake, probably have to get more partial credit, but a lot more work, especially in a short time frame that you might be given. So I hope this was helpful for you.